Well, grade 12s, let's have a look at some more limits. But now here's an interesting one. I want you to consider this limit. The limit, okay, as x approaches, now watch this, is approaching 2, and I'm going to have a very strange looking graph here, x squared minus 4 divided by x minus 2. Now if you remember in the previous lesson, what we said is if the x's are approaching 2, where's this graph? X squared minus 4 divided by x minus 2. Where's it going to? Which y value is it approaching? Well, all we had to do was sub in. So we dropped the lim as x arrow 2, x goes to 2, and we plug in 2 for x, and we plug in 2 for x at the bottom. Now what does this give us here? We've got 4 minus 4 divided by 0, which of course is 0 over 0. Now, if you check this in a calculator, you're going to see that division by 0 is not allowed, and we say that then the limit would be undefined here. Okay, but actually there's something very interesting here. You might be saying, well, x cannot be equal to 2. We're approaching 2, but when we get to 2, if x equals 2, then we're dividing by 0, which is not allowed. So let's think of it from a different point of view. Let's just take that limit again. Now watch this. If I took the limit and x is approaching 2 of x squared minus 4 divided by x minus 2. Well, let's see if we can't fix this up, get rid of this denominator. No problem. Now watch this. I can factorize the numerator, the x squared minus 4. So what I do is I keep my limit. I'm not yet substituting in. So I approach 2. I then do a difference of 2 squares. X squared minus 4 can be factorized as x plus 2, x minus 2, all divided by, in brackets there, x minus 2. Now these will cancel. And we can only do that if x cannot equal 2. Alright, which then gives us the limits as x approaches 2 of x plus 2. Now that's nice, because when we now replace x with 2, we drop the limit symbol and we go 2 plus 2, which is equal to 4. Now this is your y value approached. Now that's an important word. It's approached as x is approaching 2. But remember, at this stage at the top here, if you simply put in 2, you're going to get division by 0. So we had to factorize to get a y value approached. But I'm not sure if you really understand the meaning of that. Look at this. We start off with this by putting 2 in and we get undefined. But now we factorize here and we get a limit, a y value. This doesn't make sense. But I think I'm going to show you on a graph. If we draw the graph of this expression, let's see what it's all about. Okay, now have a look at this. If I take the graph of y is equal to x squared minus 4 over x minus 2, I'm going to factorize, and let's see what kind of graph we actually get if we simplify this. Have a look here. X minus 2. Now those can cancel. So you have y is equal to x plus 2, provided that x may not equal 2. You're not allowed to have that x value of 2, because in this original expression, and your x may not be 2, and you can only cancel if x is not 2. So what is this graph? Y equals x plus 2. Well, I've got a grid here, so let's have a look at this. But I'm just going to go below the grid and let's sketch this line. It's a straight line graph. What is the y-intercept of this line? Well, y-intercept, we let x be equal to 0. So the y-intercept is 2. The x-intercept, we're going to let y be 0. So for y-intercept, we let x be 0, and then the x goes to that. And then for x-intercept, we let the y be 0. And so what do we have here? X plus 2. 0 is equal to x plus 2. So minus 2 is equal to x. So what is happening here? The graph is cutting the y-axis at 2 and the x-axis at minus 2. And what is going on? There's something very interesting that's happening at x is 2. Well, if you think about it, if x is equal to 2, Alright, let's have a look here. If x is equal to 2, your y would have been 2 plus 2. It would have been 4. But remember, in the original, x is not allowed to be equal to 2. So what does this mean? Well, at 2, if you go to 1 and 2 there, if that's x is 2, what happens is we go up to 4, but we're not allowed. There is no y value there because it's undefined at x equals 2. I'm going to put an open dot in line with x is equal to 2, and I know that my y would have been 4. If it was just the graph of y equals x plus 2, it would have gone through there. But now what's actually happening, it would have gone through this point, 2, 4. But now x can't be 2, so we've got a straight line graph, but what it's doing, it goes like this. It goes up, cuts the x-axis at -2, cuts the y-axis there. It gets to x is 2. There's a hole there, an open dot, and then it will carry on. Okay, and it goes like this, and then the graph will carry on like that. So, in other words, on this line, we've actually got an open dot, and that happens at 2 because x may not equal 2 on the graph of y equals x squared minus 4 over x minus 2. When you simplify that, you get the straight line y equals x plus 2, but this graph x squared minus 4 over x minus 2 is not defined at 2. It's the original graph. When you tidy it up, you get a linear function, a straight line, but x may not be equal to. Now this makes perfect sense because when you work out the limits as x approaches 2, it's approaching 2, and you work this out, you had to factorize. So you factorized and you got x plus 2, x minus 2 divided by x minus 2. Those cancel. We're not allowed to equal 2, but what's very interesting, if you look at this, I'm just going to go on the right here. This is equal to the limits as x approaches 2 of x plus 2. Now when you sub in the 2, you drop the limit, you get 2 plus 2, which is 4. Now watch this. This is the limit. The 4 is the limit. The y value is the limit approach. If x is approaching 2 in either direction, the y value is approaching 4. But when you get to x equals 2, at x equals 2, the y value is not defined. So what is the moral of this story with these limits? Whenever you have the limit as x approaches 2 of x squared minus 4 over x minus 2, you try and substitute, and you plug in and you see that x is not allowed to equal 2, because then this expression is undefined. The way we get that y value approached is by now factorizing, and then we simplify the expression, get rid of the denominators there, and we have the limits as x approaches 2 of x plus 2. Now we can plug in, drop the limit, 2 plus 2 is equal to 4. That's the y value, not the y value itself at x equals 2. It's the y value approached as x approaches 2. So all you have to do is factorize and plug in, and you'll have your limit there.